Hello, my name is Kyle and today I'll be presenting the Liveness Aware Memory Allocator for HoneyPotion. This is the part 2 of the project and this video is the pre-pitch, which should be presenting what has been done and what should be done by the end of the project. I will be removing my camera throughout the presentation so that you all can see the slides. However, I wanted to say hello first. First, a quick recap. HoneyPotion is a tool that allows users to translate Elixir code into eBPF binaries in a way that is easy to use and accessible. It also gives the code generated in the process. You can get the GitHub link on the screen. Also, both languages are really distinct in paradigms and functions, which brings us to our main challenge, trying to bridge that gap. Here in the image, we can see a summary of the main difference points between the two languages. Elixir is functional, while eBPF is imperative, and so on. So, what's the motivation of this project? eBPF only gives us 512 bytes of stack. That limits what our programs can do greatly. The example below is at the limit of what we can do. If we remove the comments in entry 8, this program will not be able to run. So, what's our objective? To have a smart reallocation that's aware of variable liveness. Here you can see a small example. The smart reallocation at the bottom, instead of keeping variables, keeps memory allocations, which allows this reuse. So what's our solution? We've decided that our solution will be a greedy memory allocator with defragmentation. It's a memory allocator, completely standard, with free memory blocks and references to the memory blocks being used. More on the structure will be said later. Also, variables are allocated on the first position that fits them. That's what makes the solution greedy. And finally, if it does not fit, we defragment the memory. All used space gets pushed to the left and the empty space to the right, guaranteeing that if there is enough space, it will fit. This solution was cemented as definitive after considering alternatives and constructing simple tooling, like a visualizer for variable interferences that could possibly make the allocation more dynamic or less greedy and smarter. This tooling will be also delivered at the end of this project, even though the solutions that came from it were not decided upon. Here we can see the variable interference.graph generator, using the program on the left to create a .graph in the middle and the visualization of that graph on the right. So another quick recap. To guarantee the proper functioning of the defragmentation, it is imperative to eliminate junction points from the program. That is because two branches may have different memory states post-defragmentation, and we code the algorithm that solves this tree split. Here you can see a quick visualization of how it avoids junction points by duplicating programs after they get branched. Finally, let's talk about the structures we've implemented. The memory state is kept using three simple data structures. Two maps, one from variables to positions and sizes, and of positions to variables and size, and a list of 3 memory blocks, where every block keeps its position and size. These 3 variables represent what we call the context, which is passed along the translator. And along with that context that's passed along, we have a few functions to manipulate the structures that were previously shown. Get code value, get var pos, allocate var, deallocate code, defragment code, and also inside the memory box, get, give, and defrag. With these together, we can do the operations that we wished before. Finally, what do we still have to do? The structures and logic necessary for the implementation is complete. However, the HoneyPotion translator isn't simple, and adapting it to these structures is a complicated task. Currently, we are in the step of adding in programs one by one and debugging them to make sure they work as intended. Priority will be given to those programs that are also represented in the benchmark section of HoneyPotion, which are Hello Road, Traffic Count, ForceQ, Drop UTP, and Count syscalls. However, we do have our major roadblock, which is the eBPF verifier. It makes our job difficult in two fronts. It is difficult to make sure that every memory access is acceptable by the eBPF compiler at times, especially when accessing the memory from a pointer that comes from the heap. And second, the verifier does not give useful debugging information. If a program is wrong, it is very difficult to figure out why. So, our expectation is that by the end of this project, the new translator will be working as in-place substitute for the current translation. There are some pending issues in the current translator that might not be solved, but that is out of the scope of this project sadly. However, it can be considered for future projects and endeavors. Here you can see a few more resources of HoneyPotion, and I thank you very much for watching.